Hi, thank you to be here. You definitely picked the right track. You are the best people in the Infoshare event. Thank you. We are going to have some funny time here. As I said, I'm Gianluca, and I work for InfluxData. We are a startup in San Francisco, and we are building an open source set of projects to build your monitoring system. And everything changed during these last 7, 8 years. Containers, virtual machine, cloud computing. Now everything is moving faster, and we need to move faster as our environment is making us available to do. Our application need to grow in a way that help us to maintain it during time and make code faster and faster. To do that, we need to understand how our application behave, and we need to be ready to fail or ready to improve. It's nothing to be scared about. We have all the tools and all the methodology that help us to do that. We just need to put all together and understand how your application behave, how your infrastructure is growing. It's a good way to understand why you are failing, if you're doing some mistake, and try better than before. Time series is a language that your application speaks. We know about that from a lot of years. We are reading logs from a lot of years. We have some applications that help us to understand how our application behave. And we do that for a couple of reasons. First, because we need to trust somebody. We don't know how our application behave just looking at the screen. We need more. We need to understand how our users are using our application and how many errors there is a lot of metrics that we need to follow, and all of them come together to trust our system. Another reason is to predict the future. We are not magicians. We cannot predict what is going to happen, but based on a lot of metrics and a lot of behaviors that we are catching, we can understand if we are growing, if we are not growing, how much we are growing, and how much faster. And with all this information, we can put together a plan and maybe predict some bad event. And also because we are not John Rambo. John Rambo definitely know what to do ever and for any kind of situation. We are not John Rambo. We need someone to trust. I know him. He is a guy that usually sits in front of a laptop, and he uses a really powerful command that is called tail to read logs. That's how our application usually speak. This is a log, and we have that kind of guy that is looking at the screen really intensively, and if the logs are really, really fast, something is wrong. He knows how it works. There is a kind of normal state, and if our logs are streaming in that normal way, all is fine. If something is going wrong and it's so fast, maybe something is not working so well, and we need to do something about this. If it's too slow, there is also some other kind of problem. This is not a really smart way to understand how your application speaks, but that's definitely something. And this is the most common command that everybody is using to monitor an application. We can definitely do something better now. Logs are really expensive to store. They are descriptive. There are a lot of information inside, but to store all of them inside a database or inside something, it's a bit expensive. They are not easy to index. They are plain text usually. It means that your engine needs to work a lot to understand connection with other logs or to make your to allow you to search inside what you're looking for. They are a little bit expensive. If you have a lot of logs, or if you're using log for anything happen in your application, you need to have a good system behind you. It's difficult, but it's definitely not impossible. We have a lot of tools and a lot of services that are helping us to achieve this kind of goal, to put the log all together and try to figure out what's happening. Logstash or Kibana or Elasticsearch, some of them are as a service, some of them are open source, some of them are both. we have choice. We can definitely do a good work. Always depend on what you're doing. There are use cases where logs are really great, where you need logs, when you need logs. There are other cases when you just need to know how your application is behaving. If it's growing, if it's going down, you really don't need to know why or what's happening. You just need to know that there is some sort of behavior. And logs contain really a lot of information about what's happening. When there is a error, you know which kind of error is, or you hoping to know which kind of error you are having, and you can use logs to have this kind of information. Time series are not these details. They speak another language. But I'm not here to make a war between logs and time series. I can say that logs are a kind of time series, and you can use both, and you can take something good from logs and time series. Like you need both of them. You cannot just use time series and not use logs, because there are some problems that you need to solve with a proper logs. If you take your log and you try to reduce it to a time series and a value, it's better if the value is an integer or a float, because we can do some math on top of them, and they are easy to index and stuff like that. You are in practice translating your logs into a time series. If you think about how many logins there are in your application, how many errors you are having, or how many transactions you are doing if you are a financial company, those are all time series. Because it's a value, one login, at some point in time. It's a distribution in time. That's what time series means. That's an idea about how logs can be translated. This is not an integer, it's not a value, it's a proper log. But what I'm happy to say is that logs is a kind of time series. If you make stuff simple, you can reduce your log in just a value. CPU and a lot of information that come from your system, your servers, are time series. The CPU usage, the memory that you are using, and the network all the network monitoring are time series, and also your application has a lot of them. You can probably think about at least 5 of time series that you can take out from your application in 10 minutes. I quote this person because it's very easy to do something complicated. We are developers, and we know that everything that we did 5 years ago now seems so complicated and unmaintainable. Our goal now is make stuff simple. And when you have something simple, it's easier to explain to someone else, it's easy to maintain, and that's what I'm trying to do with time series. Have just simple value, times and numbers, and that's it. With this kind of model, you can do some math, put them together, create graph, and you have a less expensive way to take information out from your application. We have already tools that do that. Prometheus is one, New Relic is as a service one, and Elasticsearch has a model to deal with time series. And today I'm going to speak with the third one, the InfluxDB. It's an open source tool that takes care about all your time series. Okay, 1 second. Little break. Oh, you need to raise your hands here at this point. You need to do some work, I know. It's so long. I don't know. I did my best, but OK, thank you. InfluxDB is a time series database, And you can use it to take all the information that your application is generating, that your servers are generating, and you can push them to this database. And it's really easy. It's designed to be really easy to start. It's a binary that runs in a lot of operating systems, Windows, Mac. You can just install it in your servers and have it started. It uses SQL to speak. It means that you can query this database via SQL. You don't need to speak another language. You already know probably SQL, and you can just go. It's really easy to start. There are no external dependency. It's a Go binary, then you can just download and start. It supports horizontal scaling. It means that if it's full, you just need to update your servers and have a bigger server. There are a lot of people that are using InfluxDB, and there is a big community. It's open source on GitHub, and there are other projects that we are going to see during my presentation to create a full stack monitoring system. From the beginning, how to take information, how to store them in InfluxDB, and how to use that metrics to do something smart. It works with irregular and regular time series. What I mean with regular time series are information taken in a period of time that we know. For example, if we take information from a server every second, the CPU every second, it's a regular time series. If we are monitoring event like login or transaction, they are irregular because we cannot ask our user to log in every second. It's going to be weird. And these kind of metrics are irregular. InfluxDB supports all of them. As I said, there is a full stack open source set of projects that you can use. You don't need to pay, you can just download them. Telegraph is an agent. It's also a Go binary that you can download and start. It's really easy. And you install one Telegraph in every servers, and you can configure them to take information from the server. CPU, process, MySQL, if you have a MySQL service that is running, RabbitMQ. It's a plugin based. There are a lot of plugins that you can use. And it supports InfluxDB as output, but also other output. If you're using Grafana or other service like Watchlog, or there are a lot of services that you can use as output. If you have a monitoring system already in place and you are looking to have a strong collector, you can use Telegraph. InfluxDB is our storage. All the metrics that come from Telegraph are sent to InfluxDB. There are other two actors here. One is Chronograph. It's a dashboard that we provide to manage and see all the data. From Chronograph, you can also manage InfluxDB and Capacitor. If you don't like Chronograph for some reason, there are other projects that are implementing the InfluxDB output. Grafana is one of them. It means that if you're using Grafana already, you can just start InfluxDB and connect them together, and that's it. Capacitor is another open source project, and it's the last piece of our story. What we can do with our time series, that's Capacitor. We can configure it to listen of some metrics and is making proactive action on what's happening. If you think about, I don't know, CPU or network, probably if they are too high, you need to scale your application, and Capacitor can do that. You can teach Capacitor to send a post method to another application when something is wrong, and you can do whenever you want. There are other kind of alerting. Capacitor can send a message to PagerDuty, and you can be called during the night if something is wrong, or he can send a message on Slack. There are a lot of plugins that you can use. OK. I'm going to show you something about our stack. I'm using Docker, but it's just because I have it stopped. And I started InfluxDB, and InfluxDB provides a RESTful API on port 8086. All the applications that I show you and are using that REST API to send information in InfluxDB. We support JSON as output, and we have a protocol called line protocol to send information inside InfluxDB. We are not using JSON to send information in because it was too expensive. Some version ago, we was using JSON, and we understood that for the IoT market and for other market, that was not enough. And we come with this inline protocol. We have a set of SDK for a lot of languages that are translating for you this protocol. You don't need to know it if you don't like. And it supports a RESTful API, as I said, but also a UDP API. It means that you can configure InfluxDB to receive points via UDP. That is faster, and you don't know if the points are inside, but for some kind of scenario, it's also good. Now that we have it, I'm going to start Telegraph. What I'm doing here, if you're not familiar with Docker, I'm starting Telegraph, that is the agent, in my container. It means that I'm getting information from the container itself. I'm sharing the Docker socket because Telegraph is also good enough to take information from Docker itself. He do that via Docker socket. It means that I'm taking information from CPU, process that are running, but also from Docker. It means how many containers are running and stuff like that. OK. In the meantime, I'm also going to make this bigger and start Chronograph. Chronograph is the dashboard that we have, and it runs on port 888. That's the getting started. When you first start your Chronograph, it's asking you, where is my InfluxDB? It supports more than one sources, but by default, we need one. And mine is running there. The name is InfluxDB1. And it's asking me for the Telegraph database because every Telegraph is sending data in the same database that by default is called Telegraph. Oops. That's the demo. That's how it works. I forget to attach my container in the right network. Perfect. What happened here? The first page that we can see is the list of hosts that we have. As I said, Chronograph is designed to be all-together experience with all our stack. It means that it's smart enough to figure out that there are some Telegraph running, and from here we have already some sort of information about how our system behaves. Now I have just one server or one container that is running, and I have one line. Every server that you will have that is running Telegraph will be listed here. And we have the status, like my application is, my Telegraph is up. It means that probably your server is also up, because if it's down, Telegraph will be down, and it's going to be red. You have already some information. And you can see apps. Chronograph can understand which kind of information you are taking from Telegraph, and it's going to have, it has some dashboard ready for you, and you don't need to create them if you don't need. They are just basic information that you can take from the system. The idea is we know that you are getting this kind of information. It means that probably you are looking for this kind of graphs, and we are just going to create them for you. Chronograph support dashboard. It means that you can create dashboard and you can add graph, custom graph, but it's a good way to start. For example, in this case, we have information about our memory and the disk usage, the number of containers that are running, and the state of them. That's an example. You can create a new dashboard and send that dashboard to your employee or your colleagues. as I said, InfluxDB has an API. It means that there are different kind of configuration that you can do. You can teach your application to speak directly with InfluxDB and send information from the login or from anything you want. What we usually suggest is to collect all the metrics in your local environment via Telegraph. Telegraph support the same API that InfluxDB use. It means that you can send information in Telegraph in your local Telegraph, and Telegraph is sending bunch of information, chunk of information in InfluxDB every 10 seconds, 5 seconds. It's up to you to decide, and how much time send that metrics. And that's it for our demo. I can come back to my slide. That's a slide that usually I share during my presentation because, as we said, start InfluxDB and start to play with all the stack is really simple. You can just run some binaries or run some Docker containers, and you have a monitoring system up and running that you can use. But the real goal for a monitoring system is to tell you when your application, when your infrastructure or when your application is down. It means that if your monitoring system is going down with your servers, it's not working. You need to trust your monitoring system. You need to be good enough to have it separated so far from your application and from your infrastructure that you are 100% sure that it's going to stay alive when your application and your servers are down. It's not a simple goal. You need to know that, and it's not just a set of Docker run command and funny things that you can do. There is more around that. And that's it. We have a couple of minutes for some questions, if you have something.
There is anyone who would like to ask a question to Gianluca? Please raise your hand. We'll pass you a microphone.
One over there.
There is one.
Hi. In my company, we are using Elasticsearch for logs and OpenTSDB for time series. So what would be the benefit of using InfluxDB instead when comparing to those two?
Yeah, we have a set of benchmarks that we are doing to help people to understand why you need to pick a proper InfluxDB, a proper time series database and not something and not your favorite kind of database. And one of them is between InfluxDB and Elasticsearch. It means that I can show you what I mean. Elasticsearch. And yeah, depends of which kind of databases you are using. But this is the difference in write performance between InfluxDB and Elasticsearch. It's pretty big. We did this benchmark with InfluxDB 1.13 and Elasticsearch 5, and that's the difference in write throughput between Elasticsearch and InfluxDB. Like, I'm not going to show all of the graph, but if you Google InfluxDB and Elasticsearch, you can try to understand if these metrics are good for you for your use case. You know, benchmarks are usually kind of opinionated, but we tried to make them as real as possible. And we have comparison with Elasticsearch or MongoDB or Cassandra. You can definitely have a look.
I have one question. Sorry, Gianluca. Does Telegraph comes with some predefined templates that when I install it on a host, I will already have like some standard graphs? Or do I need to configure everything and push it via API?
No, if you're using Telegraph to get all the information, Chronograph has already a set of graphs that you can use. That is going, like all these graphs, I didn't create this graph. They are automatically detached in Chronograph because it knows that we are using Telegraph.
Okay, so when I configure something in Chronograph, the Telegraph will give it me.
Yeah.
Perfect. Thank you. Okay, anyone else? Please raise your hand. Oh, there is one more question.
I have a question. How does InfluxDB scale? At the moment I'm using Graphite and it scales painfully.
We don't have the sharding model open source. As a company, we have two products. One that is InfluxData Enterprise, that we are giving you the binary with the sharding model. And another one is the as a service one, Influx Cloud, and you can just start. With the open source, we don't have the model inside at the moment.
Okay. If anyone else wants to ask some questions to Gianluca, he will be available. Yep. Thank you very much. Give a round of applause.
Thank you.